let's try a couple of examples here. Um, and so this is one where I'm giving you an integral and we're going to write it using the scary summation notation. And then I'm giving you the scary summation notation, having to turn it back into an integral. Quite honestly, the way this shows up most often on an AP test is they give you something like this and then give you choices for different integrals, and you just have to pick the right one. Okay, so we're really just going to talk about like what are the important pieces that we're looking for. I think it's good practice to move back and forth between the types of notation, but I wouldn't stress too much about having to like create this thing from scratch. Okay. Okay. So, um, when I'm going to write this thing, we're always starting the same way. Limit as n goes to infinity of the sum as k goes from 1 to n. That part is going to be the same every time. I'm dissatisfied with the way my infinity looks here. Okay. So limit as n goes to infinity. So really this is saying k, remember, is the number of my rectangles, and I want to make that number bigger and bigger and bigger. I want that n to go up forever and ever and ever. And then this is where we're going to write our expression for the areas of the rectangles. So we need a base and a height. The base is going to come from the width of my interval. Okay, so if this integral is having me go from 2 to 6, that is an overall width of 4. So my base is going to be 4 divided by n. Okay, that's how we're going to start. Okay. The next part, I'm going to write it one way, and then we're going to have to rewrite it a different way in a second. But for now, I'm just going to say this is f of, okay, and we're going to have to deal with this f part in just a second. This is f of, remember, I want to think about where am I starting? I'm starting at 2, and then I'm jumping by this width of 4 over n k times, okay? Because that's how many rectangles I'm jumping through. So I'm going to write this as 4k over n, or I could write it as 4 over n times k. Okay, this is all fine and good, except this f of whatever, that's a really generic, like, expression for function, and we have a specific function here. Okay, so what's going to happen is this piece is going to become like our stand-in for x. This, when I say I'm doing f of this crazy looking thing, this crazy looking thing is going to take the place of x in this function here. So let's rewrite again. This is good practice. Limit as n goes to infinity of the sum of k equals 1 to n. All of this is staying the same, 4 over n. But now I want to actually figure out what would this look like if I took this thing inside the parentheses and put it in place of x. So that is going to look like 2 plus 4k over n squared, and then minus 3. So all I did was take this function and I replaced the x with this crazy looking thing. Okay. And that's it. That's what it would look like in limit notation. All right. Um, I still feel like this is a little bit meaningless to you because this is just a fancy way of saying take a Riemann sum and take a really good Riemann sum. And we're going to go further into the Riemann sum idea and the integral idea later on, but today is just about learning the notation. Okay, so looking at example 2, let's pick out our important pieces. Okay, there's 3 things I want you to look for. First of all, how wide is my interval? Okay, what does this spacing look like? And that comes from this number right here. This is the width of my interval. And this number here, the 4 plus, that's where I'm starting my interval. So if I'm trying to write this in integral notation, so far what I know is that I'm doing an integral that starts at 4 and has a width of 6. So if it starts at 4 and has a width of 6, it must be going from 4 up to 10. Okay. Now the question is, what is my f of x? Well, my f of x is the function that this is kind of the thing that's happening to this piece. Remember, this piece right here is my stand-in for x. Like up here, we took this crazy thing and put it in place of x. Now we're going in the other order. So this thing is what used to be x. So this square out here, this is telling me what my function is doing. And it might be a square, it might be a natural log, it might be a cosine, it might be, there's all sorts of functions that we could have happening to this thing. But for this one, this is telling me what my f of x is doing. It's going to be an x squared. And so this is, sorry, I've got too many colors here in front of me. It's an integral of the function x squared dx. And that's all you have to be able to do is say, I can pick these pieces out of this crazy notation and then write it in integral form. So you're going to practice some multiple choice questions about that in your homework tonight. Do the best you can. We'll definitely talk about these. But again, this is not the thing. Um, don't let this be the thing that like brings you down. If you feel good about all the stuff we've talked about in this unit, I promise you this stuff will come to you, because you're not going to have to build this from scratch every time. You just have to be able to pick out the important pieces out of that scary looking stuff. Okay? So feel free to give the homework a try tonight. Let me know if you have questions on anything. The homework that goes along with this assignment is a really good review of everything we've talked about so far, including your Riemann sums and all your properties. So we'll work on that tonight and we will chat about it tomorrow.